we can apply additive and multiplicative relationships to tables and graphs. Last week, we talked about multiplicative and additive relationships, but we weren't actually applying them. We were just kind of getting them off of the table. So today, we're actually going to see, if you just scroll down and look here, a bunch of blank tables and graphs, and we're now going to be applying these rules. Okay, so let's go at the top. We have multiplicative versus additive. Okay, so the root word in multiplicative is what? Multiply, which means we're multiplying. What's the root word in additive? Add, plus sign, right? And let's talk about this last week, because some people were confused. You might see multiplication, but what else might you see with multiplicative relationships? Division, that's right. And with additive relationships, you might see plus, but you might also see minus. Remember, we talked about that. Okay? Okay, when they say a parent equation, they just mean in general. We'll do it here with our multiplication, things that we talked about, like A times B, A with a dot, A next to it. These are like parent equations, okay? So, meaning we're not going to use any numbers, we're going to use all letters. So, in a parent equation for multiplication, it might be y equals ax, where a is a number, okay? Or, what did it look like for division? You guys remember? That's right, it was times half. So then that would be 1a, 1 over a. Because if it was half or ninths or fourths or whatever it is, okay? For addition, it would be y equals a plus x. And then what if it was subtraction? You remember? They didn't always say like x minus 2. What did it look like? Y'all remember? Add the opposite. So that it could be y equals negative a plus x. Or y equals x plus negative a. Those are equivalent. They just flip them around. Okay? Okay, let's talk about in a problem, words that might clue you in that it's multiplication. So if it was a word problem, tell me a word that you might hear if it was a multiplication problem. They might actually use the word times. What else? Each. Very good. Each is a great one. What's another one? Another one, Jason. Okay, that's good. What if I said I get paid every 2 weeks? Every per. Love it. Okay, good job. Now, so times each of, every per. I also have groups of and share. Share would indicate what? Division, that's right. Okay, how about words that might mean additive? Okay, you might hear the word plus. What else? Together. Come on, somebody else, guys. More than. They might say less than. If they said less than, then that would tell you what? It would be subtraction, or the opposite. What else? How about some more that means subtraction? I had this, but then I lost it, gave away, like all those, okay? Obviously, this is not a comprehensive list. This is just some to get us started, okay? A symbol that we use, usually a letter, to represent an unknown number, is called a variable. A rule using variables can be written to describe the relationship between each input and each output. So So we talked about these words last week. Input, our value of x. Remember, that was always our x. Input, circle that prefix. Input is always going to be our independent, is the word I was looking for. And that's a clue. That prefix input, independent, we're putting it in. Versus our output would be our dependent. Okay? Tell me, let's discuss these words, independent and dependent. Okay, so now we have a general rule here, which is what you do to the input to get the output. That's your rule. Well, last week, we would say the rule was like +7 or ×5. That was like our rule. It's what we were doing to the input, or x, to get the output, or y. Okay? If you look at this first table, they gave you the x, and you have to figure out the y and the coordinates, okay? Notice that they use the word process. Give me another word besides process that we can put there. Rule. Yeah. Process, just a fancy word for rule, okay? So, where they put 6x, now that I put in 0, I'm going to put 6 times 0, because I'm putting in 0 for x. So then what would y be? 0, because 6 times 0 is 0. So then your coordinates are x. Remember, x, y would be your coordinates, so that would be 0, 0. Does everybody see where I got all that? Okay, let's do the next one. It would be 6 times 1, which is 6. So then your coordinates would be 1, 6. Guys, the x has to come first. Okay? So if I put in 2 for x, then that would be 6 times 2, which is 12. So then the coordinates would be 2, 12. Go ahead and finish that out. Don't forget your parentheses when you write coordinates. Okay, on our graph, now all we want to do is just take it and transfer it from the table to the graph, okay? For the x, when x's are down here on the bottom, we know 0. Whoa. I don't know what happened there. We know 0, 0 is right there in the corner. Because I know that my x's only have to go to 4, should I put 1, 2, 3, 4, like right there? Because then that makes the graph really squishy. So what could I do instead? Every other one, that's right. I'm going to put a 1, 2, 3, 4. Now, this is my x. What's the x called? Independent or dependent? Independent. I will write that down. Guys, these are your notes. I promise you, on your next assessment, which is a quiz next Tuesday, there's several questions just about independent versus dependent. Okay? So independent, x, that's what we're putting in. Okay? Now the y, you can tell that your y value has to get to 24. So can I do it just like I did my x's? Skip every other one? Yeah, I'm going to have to maybe try my 2's. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Nope, doesn't work. Or 3's even. I'm thinking 3's would probably be good. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So that gets us there. So let's do our 3's. Okay. And this is our dependent. Because the outcome is dependent on what we're putting in. Okay? So now let's just put all of these coordinates on here. 0, 0, 1, 6, and so on. Just keep going. Okay. Now, I want to talk about what do we notice about the graph? Tell me one thing. Well, then you can't share again. What one thing you notice? Okay, so it's making a pattern diagonally. What else do you see, Allie? It goes through the origin. And what else do we notice, guys? What does it make? It's making a straight line. It's linear. We learned that last week. So, because it's linear, let's see what you remember from last week. Because it's linear and because it's going through the origin, what kind of a relationship is it? Additive or multiplicative? It's multiplicative. Yeah, you knew that also because you could see the process. But this was just another way to show you to prove that you're doing it right. Because you should get a straight line through the origin. Okay? Questions so far? Yeah. Okay, let's look at table 2. Table 2, okay? This time, our process or rule is x plus 8. So that means we're going to take 0 plus 8 to get the y, which would be 8, which makes the coordinate 0, 8. 1 plus 8 would be 9. So that would be 1, 9. Okay, go ahead and finish it out. Okay, so hopefully you remember that pi numbers, and you may not have done the same scale that I did, like being counted by, you might count it by something else. But either way, what do you notice about the graph? It does not go through the origin. And what else? What do you see? It's not? Should be. It's linear. You should have gotten that it was linear. And so that tells you what kind of a relationship is it. It's additive. Because remember last week when we talked about additive, they did not go through the origin. They were always up here somewhere. And then they made a straight line. It's an additive relationship. And again, you knew that because the process was additive. Okay? How are we doing? So they have a question. Now is a good time to ask. Okay? Let's go ahead and go to the next page. Okay, so on the next page it says sometimes you might have to work backwards to find your input value. So meaning they gave you the y and now you're going to have to try to go back and find the x. Okay? So here is still our process. So what should you be thinking? You should be thinking, what minus 2 gives me 9, right? What minus 2 gives me 9? Tell me. What minus 2 gives you 9? 11. That's exactly right. So you can fill in the input. So instead of thinking what minus 2 equals 9, what else could you think?
9.
Say it. It's the opposite. You also can think it's the opposite, meaning I have to do 9 plus 2 to get back to here. Okay? So then let's think. What minus 2 gives me 11? What? What minus 2 gives you 11? Or 11 plus 2 gives you 13. And then you just check it with your process and make sure that that's true. So if you don't like thinking of it as what minus 2 equals 9, then think right here, to do the opposite of the process. So in this case, 13 plus 2 would give you 15. And then just to check, 15 minus 2 is 13. Okay, how about the next one with multiplication? So it was 8 times something equals 16. So you should be thinking, what times 8 is 16? What times 8 is 16? 2. So what else could you have thought?
16 divided by 8?
That's right. You could do the opposite, which would be divide by 8. See? Divide by 8. So 16 divided by 8 gives you back over here to 2. Does that make sense? Double check it. 8 times 2 is that 16. Yeah. So you could either think, what times 8 is 24? Or 24 divided by 8 is 3. Thank you. So 8 times 3 is 24. What times 8 is 32? Or 32 divided by 8 is 4. So 8 times 4 is 32. Okay? Questions on that? Okay? Let's do a couple of word problems. A pizza place sells pizzas for $7 each plus a $4 delivery charge per order. If Pat orders 3 pizzas to be delivered, what will be his total cost? Okay, so let's just take it step by step. A pizza place sells pizza for $7 each. Right there, what does that sound like? Multiplication, that's exactly right, because each pizza is $7. Plus, what does that sound like? Addition. A $4 delivery charge per order. Now, I know we said per earlier, the good multiplication word, but it's per order. So during an order, how many times is that going to happen? Right, it only happens once. Okay. So now, okay. If Pat orders 3 pizzas to be delivered, what will be his total cost? Well, if it's $7 for each pizza, first of all, that would be $7 for each pizza. Do we know how many pizzas at first?
Yes.
We don't know how many right at the beginning. We're just trying to make an expression. It would just be times each pizza, correct? And then we're going to add his what? $4 delivery charge. Okay, that is called an expression. It's not an equation yet. Who can tell me why not? What's going to turn it into an equation? Somebody else. Michaela? What? Speak up, speak up. I can hear. Jacob? An answer. That's exactly right. So now what we're saying is let's actually do it. If Pat orders 3 pizzas to be delivered, what would be his total? So now instead of he, we know how many. It's what? 3. So they're $7 each plus the delivery charge of $4. Can I solve it now?
Yes.
Yeah. 7 times 3 is 21 plus 4 is 25. Now this is an equation because of Mr. Equal sign there. Okay? And don't forget your units in dollars. All right? Okay. Now, what we're going to do is take it and put it all together in one problem. We've got the story, we've got the table, we've got the graph all together, okay? It says, the Adams family is traveling at a rate of 70 miles per hour. The rule that represents this situation is 70x. Ooh, good. So I can fill that in right there. And that's where my rule goes. Where x is the number of hours. make a table to find how many hours they have driven at 140 miles, 280 miles, and 350 miles. Then graph the ordered pairs. Okay? So first we got to stop and think. Let's let our graph help us. What are these things down on the bottom versus what are these going on the side? Turn and talk to your neighbor, okay? Okay, what do you guys think these things are on the bottom? Hours, very good. Fill that in. Those are your hours. So then what are these going to go up the side?
Miles.
Your miles, very good. Okay, so now that I know that my X is my hours, I'm going to move that over here to my table. And my output was the Y. So, going back to the story, I was able to fill in 70X. What else can I fill in?
You can fill in the output and you can also fill in the transfer.
I can fill in 140, 280, and 350. Where do those go? Come on, guys. Over here, because those are the miles. So I can put 140, 280, and 350. So I know the output, I know the process. What I'm looking for is the input. I need to know what my variable is, right? Which is your variable. Okay, so now let's stop and think. We know the process is 70x. So you should be thinking to yourself, 70 times what is going to give me 140? Or I can think backwards. Instead of thinking 70 times what can I do? Divide by 70. That's exactly right. You can take that output and divide by 70. So 140 divided by 70 is going to give you what? 140 divided by 70 is going to be 2. Very good. Okay? Because 70 times 2 is 140. And then put your point. 2, 140. There's your first coordinate. Okay? How about the next one? 280. What times 70 was 280? 3? 4, right? Because 280 divided by 70 is 4. So your point would be 4, 280. And then 350 divided by 70 is 5. Now, how many of you were kind of bothered that right now that it goes 2, 4, 5? Anybody doubt? Why? Right, it's not in an equal pattern. Like you're thinking it should be 1, 2, 3, 4, or it should be 2, 4, 6. But they started by 2s and then they jumped to 1s. So, but that's okay. It should work out okay here. So then that would be 70 times 5. So that would be 5, 350. Go ahead and transfer your coordinates to your graph. What did you say? It doesn't work out? Because it gets off the graph, and that's okay. What about 0? Is 0 going to be on our graph?
No.
Well, let's think about it.
Actually, yes.
Why?
And that's not true.
Because?
It's multiplicative.
Because it's multiplicative, and because you haven't moved yet. So even if you're going to end up going 70 miles an hour, if you haven't gone any miles, you haven't traveled, you haven't gone anywhere. It's 0, 0. So I would also add that point here, because to make a straight line, we really do need 3 points, just to be sure. Okay, and then you could connect those. And we know that that 351 is off the chart. Okay? Okay. Questions, you guys? We're looking good on time. Okay, so what I'd like for you to do with a partner, if you look at the next page, I would like for y'all to do the odds only. So 1, 3, 5, 7, 9. Okay? Odds only. So those 5 columns, and then we're going to check out.